Right. Let's start the chemical properties of organic compounds. Chemical properties of organic compounds. The first one is combustion. The first reaction is combustion. Combustion reaction. As you have one chapter regarding to the combustion in class 8. So let us understand what is meant by combustion. The chemical reaction. The chemical reaction or process in which a substance or a compound reacts with oxygen present in a produce energy like heat and light. So combustion is a chemical reaction or a chemical process in which a compound, whatever the compound it is, reacts with oxygen, right, and gives some energy in the form of light and heat, and also liberate the carbon dioxide, right. Simply we can say that the burning of a compound, simply the combustion means the burning of a compound in air is called as combustion, right. So alkanes, hydrocarbons, we discussed that in the physical properties of organic compounds or the carbon compounds. Carbon compounds or the organic compounds are the flammable. They burn in the air and produces heat energy. Carbon dioxide and water. So combustion, for example, carbon reacts with oxygen. It gives us carbon dioxide on heating. Carbon dioxide plus some amount of energy also released. Similarly, methane, CH4. Methane is a hydrocarbon. Methane, a alkane. Alkanes reacts with oxygen and gives us carbon dioxide plus water plus some amount of heat or energy, right. So observe that is it balanced chemical equation or not. 4 hydrogens, here only 2 hydrogens, so we have to write 2 here. Then 4 oxygens, here 2 only 2 oxygens, 1 carbon. So 1 carbon, 4 hydrogens, 4 oxygens. We must write the balanced chemical equation, right. So similarly, ethyl alcohol C2H5OH is burns or reacts with oxygen. It gives us carbon dioxide, water, as usually some amount of energy, right. So then write the balanced chemical equation. H2O 5 plus 1 6, 3 2 are 6. 1 plus 2, 3. 3 oxygens, 2 carbons, C2. Then here we have only 1 carbon, right? Sorry. Carbon dioxide is released. So, 2 here write 2 carbons. Then 2 2s are 4, 3 plus 7. Here we have 3. 2 3 are 6 plus 7. 2 2s are 4 plus 3, 7. Now this is the balanced chemical equation. So this is about the combustion reaction. Combustion reaction. In a combustion reaction, the organic compound or the compound reacts with oxygen, which is present in the atmosphere or in the air, produces carbon dioxide and water, and some amount of energy also liberate. So as we discussed in the physical properties, hydrocarbons or the organic compounds are flammable. Hydrocarbons or the organic compounds are flammable. So natural gas, CNG, compressed natural gas, CNG. So compressed natural gas consists of methane, which is a hydrocarbon, is flammable. Similarly, liquefied petroleum gas, so or we can call it cooking gas. Liquefied petroleum gas has butane, C4H10, and propane, C4H10 and propane, C3H8. As means LPG is a mixture of butane and propane, but we have most percentage butane. So alkane, methane, butane, propane, methane are the hydrocarbons which are able to burn in the presence of oxygen and produces water as well carbon dioxide. So that's why carbon compounds used as fuels. These fuels are obtained from the petroleum. So petroleum products consist of hydrocarbons. Hydrocarbons are flammable substances because they produce heat energy and carbon dioxide on heating. So the saturated hydrocarbons, what are saturated hydrocarbons? Generally alkanes burn in the air with blue and non-sooty flame. Hydrocarbons burns with a blue and non-sooty flame. So while we are cooking, we observe that at the bottom of the outer surface of the cooking utensil, right, has no soot on it, on the surface. Soot in the sense you can call as a sticky black substance. The sticky black substance is formed on the cooking utensils. But sometimes we observe that a sticky black substance you can call as soot is also formed on the cooking utensils. This is the reason behind due to incomplete combustion. So incomplete combustion in the sense, if the compound did not burn completely or due to the insufficient supply of oxygen. Due to the insufficient supply of oxygen. So combustion means the compound must react with the oxygen. Right? In this, if the compound did not react completely with the oxygen, or if there is insufficient supply of oxygen, then incomplete combustion takes place. Incomplete combustion takes place. Due to this incomplete combustion, so a compound or organic compound burns with yellow flame, and forms soot, a soot, right? So if the supply of air for burning is reduced or limited, then the incomplete combustion of even the saturated hydrocarbon will take place. They burn producing a sooty flame. They burn with a sooty flame, giving a lot of black smoke. Right? For understanding, we are given some tips, some type of a kind of activity which is understanding in the laboratory. So the laboratory has a Bunsen burner. So the Bunsen burner has this. Here a small hole is given, outlet. So while we are and also given it has two holes around it, and also given a connection to the cylinder. So when nozzle is open, when we burn the fuel like liquefied petroleum gas. So through this inlets, it has two inlets. Through the inlets, the oxygen is supplied. So the Bunsen burner has an air hole near its base, which can open or close with the help of a sliding valve. Let us keep the air hole fully open and light the burner. So due to the sufficient supply of oxygen, the fuel burns completely and burns with blue flame. If we partially close the holes near the base of the Bunsen burner, so insufficient supply of air or oxygen happened. So due to the insufficient supply of oxygen, the fuel doesn't burn completely and burns with the flame. So we have to observe this. Similarly, the gas stove or the kerosene stove used in our homes have tiny holes or the inlets for air, so that sufficient oxygen of air is available for the complete combustion of fuel to produce smokeless blue flame. Sometimes from the gas burner, a yellow flame is observed and a soot is formed due to the insufficient supply of oxygen. So the reason behind is that burner has some holes at the inlets. So in the inlets, maybe some dust particles are maybe present. So while cooking, sometimes we observe that a yellow flame and a soot is formed because incomplete combustion takes place. So in those cases, we need to clean the burners and remove the dust particles. Right? Similarly, the unsaturated hydrocarbons like alkenes and alkanes burn in the air with yellow and sooty flame. For example, ethene burns air with the sooty flame, right? But unsaturated hydrocarbons are burn in pure oxygen. So generally, hydrocarbons like alkanes burns with the blue flame and non-sooty flame. Whereas coming to the alkenes and alkynes burn with yellow flame. Alkenes and alkyne means unsaturated hydrocarbons are burned with yellow flame and soot flame and form soot, right? But these unsaturated hydrocarbons combined with pure oxygen and produces a lot of heat energy and burns with the blue flame. If unsaturated hydrocarbons are burned in pure oxygen, then they will burn completely, producing a blue flame. For example, acetylene, or we can call as other name ethane. Acetylene or ethane, which is unsaturated hydrocarbon combined with oxygen burns with flame and produce a huge amount of heat energy. So that heat energy is utilized for flame is utilized for welding, used in welding. So acetylene is a unsaturated hydrocarbon burns with pure oxygen used in to melt the metals for burning. So that is called as oxyacetylene flame or oxyacetylene gas. Oxyacetylene flame is used to melt metals for welding. In case of welding, these are used. So due to the incomplete combustion of compound at the fuel, because of insufficient supply of oxygen, some disadvantages are there. They are leads to unburnt carbon in the form of soot, which pollutes the atmosphere. The blacken the cooking utensils and blocks chimney in the factories. The incomplete combustion also leads the formation of extremely poisonous gases like carbon monoxide. So incomplete combustion leads to releasing poisonous gases like carbon monoxide, and also leads to the wastage of fuels. Right? So based on the supply of oxygen, combustion is two types. One is complete combustion, incomplete combustion. So if the sufficient supply of oxygen, if the compound or the fuel burns completely and burns with blue flame, produces little amount of carbon dioxide and water vapor. So generally saturated hydrocarbons burns with the blue flame. Due to the insufficient supply of oxygen, incomplete combustion takes place. Incomplete combustion takes place. Due to the incomplete combustion, it is burned with the compound burned with yellow flame. Burn with yellow flame and produce soot. Then, so why these hydrocarbons or the carbon compounds or organic compounds burns with flame? As you learned in class 8, when does a material or the substance burns with flame? So when the compound or the fuel is vaporized. So vaporized molecules are the particles. Vaporized molecules are the particles of the fuel or the compound is burns with the flame. But the any compound or the fuel so does not vaporize, just burns with the red hot. Just means they did not burn with any kind of flame. So whenever we burn the coal or the wood, when we burn the coal or the charcoal, the charcoal or the coal didn't burn with the flame. So just they turn into red hot. Whereas the other fuels like petrol, diesel, kerosene, CNG, LPG, biogas, these are burns with flame because of they have some vaporized particles of fuel or vaporized molecules. In case of gaseous fuels like CNG and LPG, so they are gaseous fuels. They immediately burns and produce blue flame. Coming to see petrol and diesel on heating, first they turns into vapors. Then the vaporized particles catches the fire and burns with the flame. So this is the reason behind why some of organic compounds or some of the fuels burns with the flame and some burns without flame. This is the reason behind it. Then next coming to oxidation reaction. So already we discussed what is meant by oxidation. Adding oxygen, removing hydrogen, right? Then if any substance is combined with oxygen, we can call as oxidation reaction. All oxidation reactions are not combustion reactions, but all the combustion reactions are oxidation. Right? Little difference between oxidation and combustion. Oxidation and reduction. Let us know oxidation. Though combustion is generally oxidation reaction, but all oxidation reactions are not combustion. Oxidation reactions may be carried out by using some oxidizing agents. But in case of combustion, we need to take any oxidizing agent. Oxidizing agents or oxidants or substances that oxidize other substances. They themselves undergo reduction. For example, oxidation. Remember that all the combustion reactions are oxidation reactions, but all the oxidation reactions are not combustion reactions. For combustion reaction, we will need to take any oxidizing agent like potassium permanganate, like potassium permanganate or potassium chromate. But for oxidation reaction, we have to take some oxidizing agent. We have to take some oxidizing agent. So already we discussed the oxidation and the reduction reactions. oxidation and reduction reactions, right? So CO, for example, copper oxide reacts with the hydrogen, gives us Cu plus water something in right. So here H2 is acts as an oxidizing agent, like so like that some oxidizing agents are there in organic chemistry and even the chemistry. So we already discussed in case of oxidation and reduction reactions. Oxidation and reduction reactions, right? So here copper oxide is the oxidizing agent, sorry, hydrogen is the reducing agent, and copper oxide is the oxidizing agent, this is the reducing agent, okay? Then in case of oxidation, some oxidizing agent is required. So for example, alkaline potassium permanganate, alkaline potassium permanganate, this alkaline potassium permanganate is one of the oxidizing agent, right? Then these oxidizing agents involved in some reduction reactions. So for example, CH3CH2OH ethyl alcohol goes oxidizing in the presence of alkaline potassium permanganate. First it forms acetaldehyde, then later it is formed acetic acid. It is formed acetic acid, ethanoic acid, right? Ethanol in the presence of alkaline potassium permanganate and alkaline potassium chromate, it produces finally acetic acid. So we will discuss some organic compounds. So finally this is about the combustion. So combustion is also example for oxidation reaction, but in case of combustion, so no need to take any oxidizing agent, all the combustion reactions are oxidations, but all the oxidation reactions are not combustion.